we are very, very happy to have Ross here today, who I've actually known for quite some years now, and he's always up to fun stuff. So right now, Ross is the founder and CEO of Semio. He received previously his PhD from the University of Southern California, where he studied socially assistive robots, and he focused on principal design and computational modeling of fundamental robot behaviors, like speech, gestures, social spacing between people and robots, etc. In his PhD work, was the foundation actually for the Semio software, which we're gonna hear all about today. And Ross is also involved in so many other things. He serves in the board of directors for AILA and for the Keys Institute of Practical Robotics. He's actively involved in community building in the field of robotics and human-robot interaction, and previously served as a technical and scientific advisor to Disney, Intel, National Geographic. So you can see the list goes on and on. Fun fact about Ross, he has the most adorable dog called Zelda, who we might or might not see today. So Ross, thank you so much for being here, and I'm going to stop sharing and the stage is yours.
Well, thank you, Patricia. I appreciate the intro. I'm super excited to be here. I agree with, I saw Andrew Stout's comment. It definitely feels like March 119. Actually, today is the 1-year anniversary of the Los Angeles lockdown as a result of COVID. So I remember this day well. Let's see, let's get everything set up here. Yeah, thank you so much for having me. Like we said, my name is Ross Mead. I'm the founder and CEO of Semio. I'm going to be talking at a pretty high level about a lot of the work that we're doing at Semio right now to bring robots to life in people's everyday lives. Our goal is to define the way in which people live, work, and play with robots in their homes and in their workplaces in the not too distant future. And right now in the real world, when you ask a person if they've seen a robot or where they've seen robots, a personal robot to them is the Roomba. So it is a single purpose robot. It goes and cleans floors to the best of its ability. And as a result, you really only need one simple interface to that robot. You press a button that says clean, big old button, and it goes out and it does its job, and then hopefully finds its way back to its charger. And that's that. That's the interaction you have. But in the same way that the telephone was a single-purpose device and then evolved into a multi-purpose device with a smartphone, so too will robots in the home and in the workplace. And so robots will be helping us build our favorite products on the assembly lines. They will be in stores, giving us information about products or guiding us to those products. They'll be in our homes, helping us with our activities of daily living, or educating us when we're out of the classroom. And so, the idea is that quickly science fiction is becoming a reality. And for those of us who work in the robotics world, we would know that despite all these technological advances, right now, working with the robot is about as exciting and easy to use as the command line on the personal computer. And so I'd argue that we're in the DOS days of robotics. And so at Semio, our question is, what is the windows of robotics? How are people going to create and deploy robot applications to their robots? And how are end users who very likely don't have any expertise in robotics, how are they going to access and use those applications? And so I'm a proper robotics nerd, and so I take my inspiration from science fiction. And so I can ask anyone here, how does Luke get C-3PO to do anything? We know the obvious answer to that. He pulls out his smartphone and he unlocks it and he swipes a few pages over, goes to the C-3PO app, opens that up, goes down a few menu items, presses a button, and finally C-3PO acts, right? Of course, this is wrong. Luke doesn't have time to do this as a Jedi, and oftentimes his hands are occupied with mission-critical tools. So Luke interacts with C-3PO through natural language, both speech and body language, and that's because C-3PO is what we call a social robot. It relies on social signals to understand the intentions of the user, make decisions about those intentions, and then act to meet the intentions and the needs of the user. And so the question is, what does it take to make a social robot? Well, for us, first, we focus in on the user. We have to understand what the user is saying through speech recognition, as well as understand what the user is doing with their body through body language recognition. We focus on the robot, and so we want the robot to be able to say things back to the user, as well as make use of its own physical embodiment, generate its own body language, so it's not just a statue that talks to you. We need some sort of conversational AI, artificial intelligence, that can reason or make decisions over what it's understanding from the user and generate its own responses. And for developers, we need an overall development environment that programmers and non-programmers, such as writers and animators, can work within to build robot applications and deploy them to the robot. And so I'd say that these are sort of like building blocks for building any social robot. And it's typically the job of a developer or a company to put together all of these pieces. And you can imagine that this takes a lot of time. And so what Semio is trying to do right now is build out a platform that we call Aurora to easily allow people to build and deploy these applications. And so Aurora is a robotics software platform, purely software, that allows people to create, deploy, maintain, and analyze robot applications for their robots. The way we kind of think about this is it's sort of like what Microsoft Windows did for personal computing and what Android has done for smartphones. Aurora is trying to do for the robots that will be in people's homes and workplaces soon. We like to think of Aurora as Android for androids. An idea here is that it is cross-platform. It can be applied to a variety of different robot hardware platforms. And so a developer is targeting a single software platform and can trust that it's going to operate on these different robot hardware platforms. And for each one of those robots, we delivered three things. The first is a set of user interfaces that are standardized so that people can become accustomed to how they'll use their robots in the real world. An app ecosystem. So think of like the Google Play Store or the iOS store, the App Store, being able to get your applications and deploy them to your robots, as well as developer tools to make it easy for people to create those robot applications without having to know all the nitty-gritty details of robotics. And so we'll break each one of these down. When we're looking at user interfaces, with a personal computer, you had a keyboard and mouse. You had a graphical user interface. With a smartphone, we have a touch screen. And given the popularity of voice-based assistants, we think that natural language is going to be that interface, going back to our social robot here. But as we already discussed, for us, it's more than just speech. It's tone and it's body language that go along with that. And so we have to understand those things from the user and be able to generate them from the robot. And so some example things that you would see in us understanding information from the user, we want to identify who we're talking to. So uniquely identifying the user based on their face or their body language, their gait, how they walk. Perhaps just based on the tone of their voice, perhaps some of their preferences that we can recognize. Even if we can't see their face, we can start to infer who the person is. Other pieces are like in the lower left here, you see this is an attention recognition system. So we're trying to figure out at any given time, where is the user focusing their attention? Where are they looking? And it's not just about eye gaze. It can be, your eyes might look over here, but the rest of your body is saying that it's focused in this direction. And so we go from foot orientation. We'll start with foot orientation and starting to infer where people might be directing their attention. And we go all the way down to the distribution of photoreceptors on the human eye in predicting where someone's attention is at any given time. We also recognize things like gestures. So one of the most common ones there is a pointing gesture. And pointing is surprisingly difficult. It's not just going like this. It turns out no one actually points like this, by the way. You're typically looking at an object and your hand tends to fall somewhere on the line between your eye and the object. And so we have to recognize that, and it's something you recognize over time. It takes, maybe a half second or 800 milliseconds for us to recognize, okay, that is actually a pointing gesture versus just you moving your hands around like this. And we want to be able to take all those things and combine them when we're recognizing your speech, so we can understand if you were like this and you say, pick that up and put it over there, we don't understand what you're talking about. But if you say, pick that up and put it over there, we can understand that, and the robot can react accordingly. And then let's talk about how the robot will react, the robot output. And so there are two ways that we approach this, in either an animated way or an automated way. For the animated way, we would allow creators, typically animators, they don't have to be expert animators, but you definitely get a really great result if they are. We allow them to use our tools to create animations that make the robot expressive and allow them to do it despite the form factor of the robot. So it could be a humanoid robot, it could be a Roomba. And either way, an animator could make that robot try and wiggle and move in a way that seems expressive to most audiences. And then we have automated tools. So what you see in the lower left, for example, this is a tool for the robot to figure out where it should be looking. So, usually when we're designing a robot system, it has something that looks kind of like a head and eyes. The moment it finds a human user, it stares. So it looks at them and looks through its camera and it says, I found Patricia. And it just keeps staring because it's, from an engineering standpoint, it's locked in, it's tracking the person, it's trying to keep that person dead center. And it is terrifying. If you see this is a terrifying experience. It does not look good. It does not feel good. No one likes it. And so, well, then the question is, well, it's simple, make the robot look away. But usually when the robot looks away, oftentimes the cameras are inside of the robot's eyes, just like, our eyes are how we see the world. And so when I look away, suddenly I'm no longer seeing the user. And then I come back and for whatever reason, maybe the robot doesn't recognize it's the same user. And so it starts the interaction all over again. And so you get a lot of breakdowns in these situations. And so for us, we're trying to make it so that the robot's eye gaze as it's moving around is something that makes the user feel comfortable, but is also functional for the robot. So what you're seeing in the lower left image there, the robot will look at things that a human would typically look at. So things like bright colors, things that are very intense colors, various orientations, flickers like a flashing light, movement, those things will draw the robot's eye. And also if it's looking at a person, it's deciding where to look. So it's deciding if we're in a conversation and you're the active speaker, I might spend more time looking at you. And when I do look at you, I'm probably going to look at your face. But I'm not going to do it for too long. So there are times where I decide to avert my gaze and look elsewhere. When I look elsewhere, where do I look? And so we provide a system that allows the robot to automatically regulate its eye gaze in a way that's functional and comfortable for a user. And also another automated system that we see in the lower right, this is what we call proxemics. This is how we use distance and orientation and face-to-face communication between one or many people. And so the robot is trying to figure out where it should position itself to have a conversation with someone. And this could be mobile. So back in the days when we used to hang out in person, you might walk down a hall with someone, right? And so, where should the robot position itself as you're moving down the hallway to have that conversation? How loud should it talk when it's at that distance away? Where should it be gesturing? It makes sense for us to gesture in front of someone, but this person's oriented away. Our gestures actually change based on where someone's looking and based on how they're positioned. And so we use this information to determine how the robot should communicate both with speech and body language. So those are just some of the user interfaces. These are things that we believe will become as commonplace as the keyboard and mouse driver for a personal computer. These things will become just an assumption that one should have for their robot. And so once you've got the user interface, you want to actually do something with it. And in our case, we would say that you would get an application from our app ecosystem. And so the idea here is that developers or content creators, they don't have to be programmers, create robot applications, deploy them to a cloud-based app environment, think of the App Store, that can be deployed to one or many different kinds of robot platforms, and of course used by end users. And one of the things that we're focusing on here is traditionally, robot applications are built in-house by the company that's also building the robot. It's built by an individual or a small group of individuals, and it's a very small ecosystem of apps and content. But as we open this up to people who are not programmers and are not necessarily people within the company who are developing for a software application rather than a single hardware application, we find that this collaborative content creation allows for scalability inside the app ecosystem or the content ecosystem, which we believe will make a more rich ecosystem that people will want to use. And so, you know, to deploy apps to an ecosystem, you need apps. So how do people create those apps? And so we're offering developer tools that allow people to do this, both in terms of writing interactive scripts for robots to engage in interactions with people, as well as tools for animating the robot so the robot can be expressive. And in our case, all of the tools run in a web browser, so there's nothing to install. Sign up for an account, and you can start creating robot applications. And so here's an example of an application and showing that it can tie to all these different services. So in this case, you know, this is saying if anyone on Twitter mentions the user's handle, then the agent, the robot, will say, "Someone just mentioned you on Twitter. Would you like me to read it to you?" And then we wait for a response. If the person says yes or something like yes, then the agent says, "Okay, they said," and then it reads the tweet. If the user says something like no, then it just says okay and it moves on. So this is just a little teeny tiny script, and you can write this, someone else could write a different script, and all these things could be running at the same time. So we like to think of this as sort of like the Wikipedia of conversational content. People can deploy these interactive scripts, and as you build them en masse, you get a rich experience. The idea here is that we are building for conversational interaction, and actually what we call multimodal interaction. So it's speech and it's body language that go along with it. You can connect with third-party APIs and devices. So what we were showing there is you can connect to Twitter, you can connect to Instagram, Facebook, you can connect to your calendars, to Gmail really easily. And you can access those things through actual natural language. So actually, just to go back, you notice that as things are written here, when it says, if anyone on Twitter mentions the user's handle, that's literally how you would write it in the system. And behind the scenes, we take that and we tie that to a function call, an API call to Twitter's API. We make that connection based on what you said. So you don't actually have to be a programmer to do these things. And lastly, the idea is integrating all the assets into one framework. So if you're a robot developer, usually you're using a bunch of different tools that are all work very differently. They're designed for different kinds of people. And then you have to take all these individual pieces that have been built by these individuals and try and make them work together. And it's a bunch of square blocks and circle holes. It's not a fun experience. And we're trying to make it so that it can operate kind of all under one roof. And so you've got your dialogue-based interactions. And so you want to make your robot be expressive. So we've got tools to allow you to animate the robot. This is a spline editor or curve editor that you would see in most traditional animation software. And we've built a tool that is focused on the needs and challenges associated with robots. So dealing with things like position limits, velocity limits, acceleration limits, jerk limits, torque limits, temperature limits, etc. You can build your animation inside the web browser. You can see a virtual visualization of your robot, or you can actually be connected to it wirelessly and get real-time interaction as you're playing your animations. In the same framework, we can animate both physical joints, like the arms and torso, but you can also animate virtual joints, like things that would be on a face. And so you can do all that in one framework, test immediately, deploy immediately. Of course, like I said, we're animating our physical robot here. One of the things that's interesting about physical robots, rather than, let's say, a virtual characters, like if you're watching a film, you're watching it from one perspective. You're watching that scene from one perspective, and you are you're only ever going to expect that animation to play in the same way. It's always going to play the same way. It's always going to be that same animation. With a robot, if it's in your home, you might actually observe the robot from different positions, and the robot is going to be doing the same animation over and over again, and it can get very repetitive. And so we like the ability to add variability to the robot. Each time it moves a little bit differently. And so that little bit of variability can help add a bit of life to the platform. Other things you might want to do, you might want to make that movement change based on maybe how the character is feeling. In this case, it's changing based purely on engagement. So an animator gives some examples of animations or movements with different values of engagement. And then later, if you tell us, what would it look like if the engagement value was 0.57? Then it will generate a slightly different movement. Within the tool, you can compare these two things. So you can say, like, what would it look like in these two different scenarios? And when you put it all together, you get something that's sort of like this. So I'll give a quick explanation on this. The one on the left, the robot is moving, but its internal state is not changing. So as things are happening in the environment and in this interaction, it's not really reacting to what's going on. It's just kind of going through its animations and through its steps. Whereas the animation you'll see on the right is reacting to what's actually happening in the scene. And to be clear, this is purely animated for just for demonstration purposes. This is not a live autonomous interaction. So watch the two of them and you tell me which one you like best, left or right.
Hey, robot.
Hello. What is your name?
My name's Doug.
Dog, correct?
No, it's Doug.
I'm sorry. Doug, correct?
Yep, that's it.
Hello, Doug.
Robot, could you pick up this ball and put it on the floor?
Certainly.
Good job. Could you take me to the exhibit now?
Certainly. Follow me.
So if I were to throw up a poll here, I'd ask left or right, which one did you like better? And my hope is people like right. Hopefully both of them look pretty good. But yeah, so this is the kind of feature that we're trying to build up with our tool set. So broadly, that's what Semio is building. We're building this platform that offers this common software platform that offers standardized user interfaces, a cloud-based app ecosystem, and web-based developer tools to make building, deploying, accessing, and using robot applications easier. I know I need to wrap up here, and so I just kind of want to close with why we're working in the robotics space and what we think people can be looking forward to. What are the drivers that are making all this happen? And there are 4 abilities I'm going to say that it's making this happen. So the first is capability. So robots are becoming more and more capable every single day, certainly more capable now than they've ever been with advancements in sensing technology, compute technology, motor technology, artificial intelligence technologies, manipulation, mobility across the board. They're becoming far more capable. And as people are working in these areas to make them be more capable, the cost of a lot of the hardware is coming down, as well as the software development as pieces of software become more commonly available. So the robots are becoming more capable and more affordable. We do believe that robots are becoming more usable. If anything, hopefully we are evidence of that. We're trying to make those robots be much more usable. And I think one of the most exciting things is becoming more available. So there are more companies right now working, not just in robotics in general, but in consumer robotics than there have ever been ever. So it's a really exciting time. And so just to recap, robots will be part of everyday life. They're going to be helping us build our favorite products. They're going to be in our warehouses, helping with logistics and storage. They're going to be in front of house in stores, taking inventory or giving us information on products. They'll be guiding us to those products. They'll be in our living spaces, such as hotels, or even in our homes, helping us with those activities of daily living. And so, again, my thesis here is that science fiction is becoming a reality. And if you are interested in working towards this future, we do invite you to join us on that journey. And I will leave it at that. Thank you.
Great. This is amazing. I have a lot of questions, but I'm going to start with questions from the audience, of course. Mm-hmm. So we already have one question in the chat. I'm going to read it out for you, Ross.
Okay.
It's from Filipa Correia.
Okay.
So the question is, how do you account for personalized particularities for each context? Are those parameters, or is there any kind of adaptation? For example, the gaze and the feeling of being stared might change over time or might be different for an introvert or a person that is extrovert. And Filipa, please jump in if you want to add something else to your question.
No, it's perfect. Thank you, Patricia.
Certainly. Yeah. Well, let's talk about the contextual part first. And we're going to talk about the context associated with, for now, let's just say the application. So let's imagine that I have an application where I need to, let's make it be simple. in my world, there are 3 cubes. There's a red cube, a green cube, and a blue cube. And the goal is to, and this application is red cubes are the only things that are relevant. That application would specify within it that these are the things that are relevant, either explicitly by saying red cubes are highly relevant here, or within the natural language system, if you are referring to entities that should exist in the environment. So we have, to get slightly technical, like we have something within our framework where we refer to a scene object that you can refer to by name. If that's referred to in the NLP system, the idea would be that in an attention generation system, those things become more salient, they become more relevant. So if the robot were looking at a red cube, green cube, blue cube, simply the fact that it's running this application, the red cube becomes more relevant. So that's an area where contextual information can help. Also, if I say things like, look at the red cube, you'd like to say that, you know, the red cube suddenly becomes more relevant. When it comes to personal factors, so things like introversion and extroversion, those are things that certainly could be parameterized. Right now, they're not. But those definitely be things that we can do in the future. All of these behaviors we definitely see moving forward. All of them are parameterized, not just for the environmental context, not just for the individual, the context of the individual, but also for the character. The character themselves might prefer more or less eye contact. And so that's something from a brand perspective. When we work with companies who are building characters that they want to be unique and engaging, that's actually a design consideration. Do I want this to be more of a staring character or one that just makes less eye contact? And so that would be something that we would want to parameterize more in the future. Great question.
Thanks, Ross. Kim, do you want to mute and ask your question?
Yeah, hey Ross. First of all,
Thank you.
thank you for the talk. This was really, really interesting and quite impressive. So great job. So I have a question about your, it's more of a research question. I'm wondering, so this autonomous animation system you have somehow encodes, you know, those latent variables, right, that represent like high-level features of the motion and the expressiveness into those labels. And so I was wondering how you went about putting this knowledge into these features. And the second part is, how well does that knowledge generalize to different platforms, since this was one of the things that you were interested in specifically?
Yeah, that's a great question. So let me rephrase let me make sure I understand everything correctly. So for example, in the video I showed, engagement was one of the dimensions that it was moving along, right? And so if I understand your question correctly, we're wondering, how does it know what engagement means, and how does it know to express engagement on the platform?
Right, because you mentioned the parameterized keyframe based system. I was wondering if that's what you were changing, or was there more than a family of animations that were hand designed?
Sure. Yeah. So in this case, all of the like a lot of the core body expressiveness. Let's just start with why we do this. So a lot of my work originally was on automating body language, and two things. One is when you're going across a variety of different robot hardware platforms, it's really difficult to get consistently compelling expressiveness across the board. Like you can do it, but it's challenging, and sometimes it's just not consistent. But the biggest reason for us, as a company, is we work with big companies who are like, we have like 400 animators on staff, and their sole purpose of existence is to make our character move the way we want it to. And so if I'm trying to deliver to them an automated method to do this, they'll kick me out of the room. So for the most part, they're interested in actually animating the character so it is on brand for them. And so that was a revelation, years ago when we first started the company. So now I can build these animations, but then how do I do things like engagement or confidence or happiness levels, extroversion, right? These different dimensions, they specify those. So we also don't say, we're not saying here's the emotion model you should be using. Here's the personality model you should be using. If you want to ask me, I can give some general advice, but at the end of the day, they specify the dimensions that they care about. It could be X1, X2, X3, and then they give examples in each one of those dimensions. So the animator goes in and says, here's what it would look like with this set of parameter values. Here's what it would look like for this set of parameter values. And then they can, in real time, scrub through that and say, what does it look like with this other set of parameter values? Do I like that? If so, move on. If not, provide a new sample at that level. So yeah, we actually got away from trying to use standard emotion models, standard personality models, standard sociability models. Again, I can recommend some to companies, but we don't focus on any one set.
Cool, thanks.
Yep.
So we have another couple of questions actually in the chat. Let's see here. So Andrew Stout, would you like to ask your question or should I read it out?
Uh-oh.
Sure. Great talk, Ross, and happy birthday.
Thank you, bud.
So high level question to you as our token industry representative. After the failures of several prominent companies, are we in a consumer or social robotics winter? If so, how do we get out? If not, why do you think not?
I hesitate to call it a winter, and it's kind of feeling pretty cold though, isn't it? So I think a lot of the challenge that there are a lot of challenges that these companies faced, right? And I think one of the major ones is that the company has to do everything. So they have to build the hardware, which means they have to figure out all the manufacturing stuff, right? Then they have to build the software infrastructure. So we found that, on average, about 75% of the time that the software developers at these companies was spending was purely on integration. It wasn't building out new application software. It was doing just pure integration, taking existing technologies and making them work together into a cohesive framework. And then once they've got that, then they have to build the applications. So they're doing everything. So you're building it'd be like building your personal computer and building your operating system and your drivers and building the applications and hoping that you win, right? I think with drivers such as voice-based assistants, people are starting to get used to these natural language technologies. I think a lot of new natural language technologies are coming out that are going to make it easier for people to integrate those capabilities into a robot. And in the next few years, I would say that it's going to allow the robot companies to focus more on building applications that actually provide value to customers. After that, so let's call that the next 3 to 5 years. After that, I think what's going to happen is you'll see more third-party developers who have reason to build applications for robots because they will be out there, and I think they'll be targeting a software platform, not a hardware platform. And with the idea that if I write an application, I don't have to choose which hardware winner there is. I develop for a software platform, and so long as enough hardware platforms have adopted that software platform, my possible market share there is the amount of robots adopting that software platform. And so I think at that point things start to things start to get warmer for the social robotics world. Do I think this is a 3 to 5 year industry? No. I think this is a 5 to 10 year industry, and I think that things are going to be pretty chilly for the next few years. Okay. By the way, of anyone in this room right now, I'd be willing to bet that Andrew has the most experience in this area. So I'm looking forward to Andrew's critique later.
Thanks, Ross.
Okay, we have a question from Glenda. Glenda, would you like to ask your question?
Yes, can you hear me?
Yes.
Okay. Yeah, my question is also in the chat. But I was interested in this idea you showed in the beginning that you will have more ordinary and maybe a lot of people being the creators of the content and the programming of these robots, and how that kind of feeds into this broader discussion of responsibility and ownership, because what we see with the social media platforms like Facebook is that the more people get in, along the way, people also realize they create the content, or they have to suddenly be better at know how to behave there, because they somehow feel responsible to have good discourses because it's consequences for democracy and blah, this kind of thinking. And I was just seeing some parallels maybe to what happens as with robots as products, because right now we see them maybe more as, this maybe gadget or one standing alone product. But in the future, if they really become this joint project that we all benefit for or can contribute to, how does that change our view on the robots like that, and our responsibility? Is it just the people who then, as you mentioned, have the biggest market share on the platforms, or is it something we need to distribute? Like, how do we deal with that as a society?
Let me just, I think the easy question, or the easy answer to that is I have no idea. That's the summary of anything else I'm about to say, which I haven't figured out yet. I kind of going back to this notion of the Wikipedia of conversational content. I think that a pretty fundamental part of this is going to be moderation. And even with respect to that, that is assuming that you have good and trusted moderators, right? So if people are building out these applications in a public way, the idea is that as people are building applications, anyone can use it, anyone can view the application, anyone can modify it, anyone can copy it. At least that's with our free and public model. In those situations, someone could go in and propose edits. Someone can go in and accept those edits or reject those edits and give feedback on those edits. So hopefully over time you're seeing a representation of hopefully the best of society. I'm not sure how that will necessarily turn out. So if anything, I feel like we're running that experiment, and we'll let you know. That's what I got.
Thanks, Ross. And Glenda is our dear philosopher in the field of HRI, so I'm always looking for her questions. We have one more question.
I'm a dear computer scientist who got lost as an entrepreneur.
Right, the field is convoluted with these things. Yeah. We have another great question from Nicole. I wanted to ask you if you want to actually ask your question yourself.
Yeah, sure. So happy birthday, Ross, and nice to see you. So great talk, first of all, and then my question is more related to also your experience during your PhD. You have worked with in understanding socially assistive robots. So our robotics basically can support people with special needs. And I was wondering if in your vision, do you have any idea of providing the developer of robots also of an accessible toolkit? So I mean, I have some experience with, for example, accessibility plugins or toolkit for website development. So I was wondering, why do not provide the same kind of tool also for robots?
Certainly, and if I understand correctly, we're talking about, well, there are two ways that I could see approaching this. So one is improved accessibility for development tools for creating a robot application, as well as just general improved accessibility as you're interfacing with a robot directly. So if you were to say that in the same way that websites have accessibility features to help people with let's say hearing or visual impairments, ideally the robot's able to do the same. So with respect to that, we have explored actually primarily more during my dissertation, things like having the robot automatically adjust the volume and pitch of its voice to accommodate for people with hearing impairments, or perhaps gesturing differently or moving differently as it's interacting with people with visual impairments. So those are some of the accessibility features that I feel like I would like to see in the robot itself. In terms of the developer tools, there are a lot of challenges there because especially right now, a lot of these widgets are custom, right? And so this is something that, you know, we've talked about this internally. A lot of these problems we're still trying to figure out how to, you know, how to build a first version of anything. So a lot of these things are custom. And so accessibility is something that we discuss internally. Have we executed on that at any level of is it sufficient? Definitely not. But I mean, that's something we definitely need to do. And just on a side note, there's been some really great work in the past few years from a friend at the University of Nevada, Las Vegas, from Andy Stefik, on working with people who are blind or have visual impairments who want to code. And I think that's some really exciting work, and that's stuff that I kind of like to use as motivation for some of the things that we would do in these interfaces.
Thank you.
Yeah.
And now we have a very interesting question from Sylvia.
Hi, Ross, and thank you again. Happy birthday again. And so my question is related to what Andy was asking, because he also was mentioning the failure of some companies in robotics. And I think like you kind of answered also by mentioning end user development tools and accessibility tools can help maybe in building those capabilities that are missing in robot, and that might affect the success of the company that proposed them into the market. But my question is, despite this interesting of integrating social capabilities, this capability seems to be less relevant than others for robotic company success, because Roomba or other, like even toy robots, but that still are toy robots, have other functions that are outside, like being social. So it seems to be like interesting research topic, but still something that disconnects from business. But you are in business, so this is why I asked.
Sure. So if I'm understanding correctly, you know, actually, I will interpret it as, you know, is social really the thing? Or it's kind of how I'm thinking about this. So I feel like the social element is primarily the user interface. So to back up a little bit, again, going back to the Roomba, right? Because it's doing a single task, it makes sense that it's, you know, it's a button press. You know, some of the functionality with Roomba might allow it to be more selective in some of the tasks that it's doing. So I might be able to say, go to the living room versus the master bedroom, right? So now at that point, I might start using an app to do that. As the number of options becomes, you know, sufficiently complex, you are having an alternative interface, something like speech. And intent recognition on speech or gesture allows us to really explore all the different possibilities of things that the user might want to do. But I think that the social element is simply that user interface that makes all this more interesting. I don't think that's why people are going to be buying social robots. So, you know, one of the questions I think we should all have, and I'd be very interested in other people's opinions, is what is the killer app for robotics? And I guess we shouldn't use the term killer app, but you know, hopefully you know what I mean. What is the spreadsheet of robotics, right? What is the thing that everyone really wants? And at least in our research, like a lot of the things that people talk about pretty much boil down to find and fetch, right? So go find this thing, which is a perception, which is a mobility and perception problem, and fetch it, which is a manipulation and mobility problem. But to know what to go find and fetch, you're probably, you know, I would say you're probably going to get away from a desktop or a mobile interface in real world applications. So the problems that we need to solve are going to be mobility and manipulation for, I think, people to really start adopting these things en masse. But the way in which they'll get that kind of functionality, I think, is going to be more of a social user interface in nature. And so I think it's going to take all those things to really make any form of adoption really start to take off. And again, it's debatable as to how long that's going to take. I am actually optimistic that it's a closer journey than or a closer destination than maybe we think.
Cool, thanks. I like your definition of social related to the interface. So maybe we can discuss later other questions.
Thanks, Ross. There is one more question from Andrew McGregor. Andrew, would you like to ask your question yourself?
Hello.
Hello.
Hey, buddy.
Hey, happy birthday, Ross.
Thank you, bud.
Thanks for the speech. I was wondering, given kind of the expected length of time before larger commercial development, if you have like a Semio space in VR somewhere that people could play with Semio's kind of thinking. And yeah, do you see your work as only being physical, particularly given the pandemic and how there's far more need for remote things now?
So that's a great question. So actually right now, like literally right now, we are actively working to integrate and deploy our applications in VR. So right now we're integrating with the Unreal Engine so we can easily demo off a lot of our behavior recognition systems. So you're not using paddles and stuff to do that. You can actually just gesture and talk and interact with the environment. As well as being able to visualize things like the 3D robot in the environment that you can interact with in that space. Kind of going back to the previous question, Sylvia's question, the moment that that you're trying to do physical interactions in the real physical world, that's when I would say that we start to necessitate a robot. And so things like VR and AR, I feel like they start to become less functional if you need physical interactions with the environment. I feel like for us, our focus, even though we are doing stuff in VR, that's primarily for demo purposes. I don't think we're really going to actually push out the product in that space. Don't hold me to that. But I feel like a lot of the things that we solve right now are inherently physical in nature. When we started Semio, we started with this notion of digital characters, both on screen and physical. And we kept finding that there was such a difference in the challenges faced by virtual characters versus physical characters, primarily just due to physics. And so we thought, you know what, let's just focus on robots. Let's focus on the niche market that we believe is poised for growth and be part of that as it does grow. So yeah, usually I tell people, if you're animating an on-screen robot or on-screen character, there are better tools to use for that. If you're animating a robot, you should be working with us.
Well, thank you so much and congrats.
Thanks.
Okay, so we're going to the last question. I'm going to ask Karen to speak up the question.
Yeah, thanks. Thanks for organizing this. This has been great. Ross, hi again. Happy birthday. And also my question kind of links back to what everyone has been mentioning a bit, but I'm going to go a bit direct and ask what have been the use cases Semio has been used for. So what are the use cases you've been seeing such tools being used in, and what have been the challenges of you actually going out there to customers and being like, here's my solution, you can use it, you know, and what are the challenges really in selling robotic solutions? And probably the third one to kind of link it in is what have been the outcomes. So say you managed to convince them to buy the solution, say there was a specific use case, right? After that, what have been kind of the effects you've been seeing of having such solutions to solve a certain use case versus not having them?
Sure. So I think I lost track of all three questions there, but I think generally, I got use cases,
challenges of selling,
challenges. There we go,
and then effects.
Got it. Okay, cool. So use cases. Let me preface this with So Semio, at this point, we've intentionally not taken in any outside capital from traditional, like institutional or strategic investors. We have almost exclusively bootstrapped the company based on sales revenue with large enterprise customers. The reason I say that is because those large enterprise customers are extremely secretive. And as a result, I cannot speak to what we're doing with them.
So I can't know.
Well, no. So, but I can speak to other other use cases. There are three general use cases that we have targeted just ourselves. So the first is entertainment, then education, then assistive, in that order, because we believe there's actual market potential for that right now. Moving forward, we believe that potential is flipped: assistive, then education, then entertainment. And so that's generally like the areas, the verticals that we are looking to support the most right now. The areas where the use cases we've actually deployed. Two of them, they're actually both related to the same platform. There is in the research world, there's the Corey robot, which was done as a collaboration between the University of Pennsylvania and the University of Southern California. And so we're actually providing the core software stack for that that integrates with ROS. So that's primarily for the HRI research community. And then another project that we have with them that has actually been deployed is in a assisted living center in Philadelphia, working with older adults. And so we've seen it deployed there. In terms of outcomes, literally analyzing the data right now and trying to submit a paper on that. And in terms of the challenges, I'd say the biggest one for that's my favorite part of that question because it was the thing that hit me the most going from academia to industry. So coming out of academia in the research world, I thought I had all the answers. And when we went to go start selling that stuff, pretty much the response we got was like, "You're solving problem 1,000. We need to solve problem 1." And so, we had to really start to work our way back and figure out what are the problems that people actually have right now in the real world in developing products that they can actually, deploy. And so we really had to take a step back on that. And one of the areas that I realized early on that was not as appealing in industry were a lot of the learned models that we were using, either for dialogue systems or for expressiveness. Oftentimes, either a data set is not available, or even if the data set is available, there are legal and marketing practices within a company that prevent you from using a model where you can't say, if this comes in, this comes out, kind of thing. And so, and also you tend to have creatives at those companies who would say, even if legal and marketing sign off on it, internally, they don't want those things. They just don't want them. And so for a bunch of reasons, a lot of our machine learning techniques were kind of put on the back burner, and we focused more on really what is something that would fit into the existing workflow within a company and make people happy there.
All right, thank you.
Yeah.
Okay, let's applaud Ross and thank him so much for all of this Q&A. Super, super interesting. Thank you, Ross. So I'm just going to close the session. Very fast because we are a bit out of time, but join us for the next session. In 2 weeks, we will have Filipa presenting about group intelligence on social robots. So we look forward to seeing you on April 2nd. And you can always support us in Buy Me a Coffee, of course. And thank you so much for being here. This has been incredible, and we look forward to see you in 2 weeks.